Okay, good evening, ladies, gentlemen, and those who still haven't decided which you want to be yet. This is an Epiphone Blues Custom. It's a pretty cool tube amp that's been around a while. Mine has had a bunch of tubes played around with, and I've tweaked around with the gain stage and got it the way I like it. So here's the dilemma. I actually made one once before for it because I had parts, and then I sacrificed it to something else. We can switch channels here. I just have it in standby. When you're on channel 1, which is the clean channel, you have green. When you're on channel 2, it's red. And I wanted to get the Footswitch for it. So I was at the store, and these have not been around for a while, but I found this white Footswitch that channel 1, 2, and then DSP. Well, that would be the reverb, right? Well, yeah, this is not quite the Footswitch for this amp. It sure looks really cool with the amp though, right? But here's the problem. So we'll put it on the drive channel. Hopefully you can see the light. I don't know if you can or not, but I'll push this in the plug there, and it goes to channel 1, and I click the switch and the LED goes on and off, but it's not switching channels. And I click on the reverb one, and the LED on the Footswitch goes on and off, but it's not changing channels. So if it's not changing channels, it's not working. I have dealt with this once before. It usually has to do with an issue with the LEDs and the lights. If we look down here, there's a Footswitch I have down there that it used to have LEDs in it, but it doesn't anymore. And that went with this PV Encore now. But the voltage for the Footswitch, the controller voltage for this, is so low that it doesn't really jive with LEDs. I mean, any kind of voltage drop on that Footswitch line will just jack it up. So it's running without LEDs. But this one, I believe this is a relay. Let me hear it. Let me listen. Yes. I'm pretty sure there's a relay in there. And I think we can make this work if we just twiddle around with the values of the resistors. So we're going to put this on the bench, pop it open, and have a look. So we're just going to leave the amp over in standby mode for now and just leave it on. It's not going to hurt anything. And we'll take this over to the bench and open it up. Okay, so I'm looking at this, and this is actually a double pole, double throw switch, but they're only using half of them. There must have been a sale at the warehouse. So we have, appears to be, this would be the channel lead, right? That's channel, yeah, channel 1, 2 is this one. So we have the N, and this would be the signal there. Or is that, do I have it backwards? Is the copper the earth, or is the copper the signal? Let's see, which one would be the earth? Usually I would think the copper would be the earth, but it doesn't look like it. It looks like we have 1 black and 2 copper. So, okay, so if this is in the this would be, let's see if we got this switch right. It should be whatever's connected to the middle would be either on this point, which would leave all this stuff open, or close here. So what the heck? Let's play with our meter a little bit and make sure I've got how it works. But let's see. So if this is engaged, that would connect to this and that, so that would come through here. That would pass the signal through. It would have to go to the LED to come back through. In the off position, middle would be connected back here to nothing, I think. Yeah, let's go get the meter. Let's make sure I got this right. Okay, so I figured out how they have this working. This would be your center point. This is contact number 1 or contact number 2. So one of these is your neutral, or one of these is your ground, and one of them is your plus. And I haven't really figured out which one's which yet. But when it's in the forward position, essentially it shorts these two together by way of running this to this. When you take it and flip it so these two are connected, the current has to flow through the light bulb to get back, and it doesn't make doodly squat worth of sense to me. So I'm going to just take these wires off, think about it for a little bit, and do a little quick experiment. Okay, so I took the cable out of this mess, and it was a little deceptive because they reused this and confused me onto what the cable actually looked like. So we do have a grounded shield. I kind of tinned it half-baked here, and then we have the clear conductor and the black conductor. The clear conductor, when you short that to the braid here, which is the ring or the ground earth, it will switch to the clean channel. When it's open, it's on the drive channel. And then this one, when you short it, it will do the reverb. I have to check which is on or off, because I would assume on would be disconnected. That makes the most sense, and I'll double check that. But off would be disconnected, because that's what it would want to be on in default, and then, you know, click it there and go off, because it would want to be on by default. Right, because open would be on. If you think about it, there's no foot switch in there. Open would be on, closed would be off. And you can hear the little relays ticking in there. So the simplest way to wire this, but I have to see what I wonder what the resistance is through those bulbs, if I can tell. I have no idea what kind of voltage drop we're going to get, or what kind of diode, or what we're going to get there. So let's see if I can actually measure a resistance through those. Maybe we can. It must be in the wrong position. Yeah, infinity. So let's see if it'll do anything in diode. Of course it won't. Why would it do that? And of course nothing. I can't tell if these are light bulbs or LEDs or what they are. Hard to say. Crap. Now let's experiment. Let's see what happens if I just run that through there. Okay, so the light bulb lights up and it switches to the clean channel. So there's not enough voltage drop in there to kill that. And over here, it must be clicked. Okay, so it won't click there, and it will click here. But I don't see the bulb coming on, but I can't see the bulb from here anyway. So I can hear the relay chattering away, but I don't see the bulb lighting up on the reverb side yet. I think I did see it light up just a second ago. Yes, okay, so it is lit. Okay, so that's okay. So the bulbs, these bulbs are going to be okay. Now we just need to figure out how to wire them the way I want to wire them. Alright, time to think for a minute and scribble. Okay, so just fooling around with my alligator clips, what we basically determined is this diode has a very, very low drop. So I basically have this functioning as an on-off switch. There's our positive, there's our negative, and there's our diode. So if I turn it on, the diode will light up and it will be connected together, which will be the clean channel. And we click it again, and it goes off and it goes to the dirty channel. So simple way to wire it, but that'll work. So we'll solder that down, and then we'll do the same over here, and we'll have a foot switch that works with the Blues Custom, and it will have lights. Yay! I kind of wish the light worked the opposite way, but I cannot think of a schematic that would work for that without getting way over complicated, so we'll go with this. Okay, I figured it out. Essentially, I would rather have the LED on when the drive channel is engaged, but there's a relay in the amp, so if the relay gets enough current to switch, then it goes to the clean channel, which is what I don't want. So I figured it out. If I have, here's our positive, okay, so here's our positive. So if we're in the, if this is open, if these two are not connected, no current, or not much current is flowing between these, the amp is on the drive channel, which it is now. And so when the switch is in the drive channel position, which is this position, this can go here and then there. So this is the plus of the diode, or the LED. So the LED is going to be looking to get this to ground. So if I can get this to ground without putting too much current on there, enough that it can get back to the relay and trip it, it won't trip, so I can get the light on while it's on the drive channel, which is what I'd prefer. And I played around with a few values. The LED is bright enough that I can see it well, and it will not trip the relay if I use a value. This is 3.8K, so I'm going to put the minus lead here, the plus lead here, and then we're going to jump the 3.8K resistor across here, and then we'll get the desired operation for this channel. Yay. Okay, I'm going to zoom in here to what we have so far so you can see it. The reverb is the same way. It's on when the leads are open, so when this is not to ground, it's open. If we were to put that to ground, now that closes the circuit and the reverb stops. So it's going to be, these two are going to match. So what I have on the switch is I have the positive lead here, I have the ground coming in, the braid shield on the wire comes in here, I have it brought over here with the orange wire, so those two are interconnected. So this is the channel switch positive, and when the switch is in this position where these two are connected, which it is right now, that would be in the drive channel, which would be where these are open, quote unquote. They're not technically open because there is connection, but it's through the diode and through the resistor, and that is approximately 3.8K, and the light is on sufficiently for my standards. I push it, the amp switches to the clean channel. So we're going to essentially mimic the same thing for the reverb side. Okay, so I did the reverb the same way. The resistor is kind of positioned a little differently, but that's just coincidence. So our lead comes in, the shield, which is the ground, I have tied to these 2 points. The power lead for the reverb is here, so when it's connected here and shorted, that would put the reverb off. When the reverb is on, it would be, the relay would be open, but current can flow through the diode and then through the resistor, and the resistor eats up enough of the voltage that the relay inside the amp does not close. And this is a lot easier to do on relayed amps, like that PV Encore does not have relays, and trying to do a switch like this doesn't really work too well. So I had to leave the lights out. I don't believe the original PV switches had lights anyway, but I used a generic switch and made it work. I'm glad I thought of trying the resistors. Now I have the order that I like, where when we're in the drive channel, the light is on, and when we have the reverb on, the light is on. So that's the desired operation here. So that's our wire. This is the plus side of the diode on these. This is the plus side of the light emitting diode. So we'll close it up and give it a final test. Okay, so I found a dilemma. The reverb isn't switching like it should. So what I'm thinking, when I put the resistor on there, see, I should hear it switch, and I don't. So it's on, but it needs to go off. So it's not switching, so I need to change my resistor value. I probably need to go up a little bit. There's still too much current flowing. Or is this normally closed? Hold on. Let me do a little brain thinking here. Let me experiment for a minute. Okay, so this relay is a little bit more sensitive. I can have... It will stay in whatever position it is with this particular resistor, but we're going to need to up this resistor value a little bit. It's 3.8K. Maybe we'll try something more like 4K-ish, something like that. So I'm going to have to take this out, and then we'll try a slightly larger value resistor. We want to keep the LED bright enough, but we need to make sure we can trip that relay. Okay, so after experimenting a little bit, it looks like about 5K would work. It seems to illuminate with up to an 8K, so if you've got anything from like 5, 6, 7, that should all work. The lower value you can go, the LED will be a little bit brighter. It's a smidge dimmer than this one, but this is all really low voltage, so. But that's enough to make the relays trip, so we're going to put this 5.1K resistor in. Okay, so with our 5.1K, we're going to double check the operation, and hopefully the next video will just be the final test.
Okay, so we're going to test the final operation of our Footswitch that I thought was for the Blues Custom, and I bought it and put it on the shelf for like a year, and then I went to use it and found out it wasn't the one for the Blues Custom. But now it is, because we made it so here on our channel, where both lights on the Footswitch are off, and we should be on the clean channel with no reverb.
That works fine. Let's try the reverb. That light lights up adequately bright. That's too much reverb to be useful, but it's just to prove the point and make sure our crummy camera can pick it up. And then we'll try the drive channel. Drive lights on. Alright, and let's try drive with reverb just to make sure they both work together. Yes, it does. Alright, cool. So now I have a Footswitch for my Epiphone Blues Custom that I didn't have before, and it works. Yay! So, for most amplifiers, Footswitches are not rocket surgery. Sometimes you get, if you have a schematic, you can see what the thing wants, but usually it's a matter of when, if it's a two-function switch, you've got your, tip, ring, sleeve connector, And when ring is shorted to sleeve, one thing when ring is shorted to sleeve, one thing happens, and when tip is shorted to sleeve, another thing happens. And they're pretty. You can figure them out through experimentation. That's how this one was done. I'm glad the lights are bright enough, and I was able to get them to function the way I wanted to. Natively, it would have kind of been opposite, but using the resistors and trying to run current through the light without running too much through the relay to trip it, we got the operation desired. So we'll go play our victory song and call it a win. Thanks for watching. Have a great night.